Good morning, Ratbags. Welcome to Matric AP Corona Maths. And today we're going to be looking with graphs involving ln and E. And we're going to be working from your Mind-Born Maths, Algebra and Calculus AP book, exercise 6. And as examples, we're going to do question 1A, F, K, L, M, T, U, V, Z, and question 2A, Y. Thank you. Just got some fans in the background. Groupies. In each question, it says you have to first find the asymptotes, then the intercepts, and then sketch. And just remember, graphs involving e to the x, you're going to have the same technique that you used with normal exponential graphs that you did in core. Generally, we label them the key points in terms of e, unless they specify to 2 decimal digits. So a couple of other things. Remember, e is approximately 2,718. Ln of e is 1, and ln of 1 is 0. That can solve you a bit of time. I would always try to do the graphs first, and then have a look at the solutions that we do together. So we're going to start off with question A, which is sketch y is equal to e to the x. Well, if you had y is equal to 2 to the x, you know that there'd be no vertical shifts. So first of all, what's your horizontal asymptote going to be? It's going to simply be y is equal to 0. Tick. Then what I always do with any exponential graph, to get an idea of what's going on, I always choose the points -1, 0, and 1, and I supplement. So when x is -1, you're going to get y is equal to e to the -1, which is 1 over e. So one point that we've got on the graph is -1, 1 over e. When x is equal to 0, y is equal to 1. So another point that we've got is 0, 1. And when x is equal to 1, y is equal to e to the 1, which is simply e. So another point that we've got is 1e. So we've got 3 points, 0, 1, -1, 1 over e, and 1e. So, and we know the basic shape of an exponential graph. The asymptote is y is equal to 0. So when x is 0, y is 1. Make sure that's labeled. Remember, you don't have to have the whole scale. As long as your intercepts are labeled and it looks roughly okay, that's fine. You're not trying to draw work of art. Okay, just get the basics right. A lot of you spend too long, okay, making these beautiful diagrams. Then, when x is equal to 1, y is e. E is about 2,7. So when x is 1, y is e. So it's simply going to be label that point 1e. And when x is equal to -1, y is equal to 1 over 2,7. Okay, 1 over e, which is pretty close to the axis, roughly there. So you're going to label that -1, 1 over e. Show that the graph is heading towards your horizontal asymptote, which is the x-axis. And draw the darn thing. And there is a graph of y is equal to e to the x. Okay. Right, so that's your standard graph of e to the x. Right. The strategies we're going to use are still the same. The next one, question F, go try to do this. Go sketch y is equal to 4 e to the -x. Give it a go. Do your horizontal asymptote, do the table, you've got your 3 points, draw it. Let's label it once again in terms of e. Okay. So, your horizontal asymptote, well, there'll be no vertical shift, so it's still going to be y is equal to 0. When x is equal to -1, you're going to get 4e to the -1, which is just 4e, which is 4 times 2,7, which I think is just under, I'll check now. Okay. When x is equal to 0, y will be e to the 0, which is 1. 1 times 4 is 4. So we've got the point -1, 4e. We've got the point 0 and 4. Okay. And when x is equal to 1, you're going to get e to the -1, which is 1 over e. So you're going to get 4 over e. So the other point is 1 and 4 over e, which is 4 divided by 2,7 something. So if you want to get an idea of your calculator, what 4e is, and 4e is approximately, I think, 10,9. So that's negative 1, 10,9. But I'm still going to label it as 4e. The 10,9 is just to see roughly where you are. So negative 1, 10,9. I've gone up in 4s. Let's make it over there. So we're going to label it negative 1, 4e. When x is equal to 0, y is equal to 4. So there's another point at 4. And then when x is equal to 1, y is equal to 4 over e. Puts up somewhere roughly there. As long as it's labeled 1, 4 over e. So this is a decreasing function. And when you draw it, that's all that you need. Right. Get those down right bags. Hope that's okay. Bonjour. Right. The next one we're doing is k. And you've got to sketch y is equal to 2e to the x plus 1 minus 2. And I want you in this case not to label it in terms of e, but label your key points correct to 2 decimal digits. Right, the first thing, what's the horizontal asymptote? Give this a go. Try it first. Do your horizontal asymptote. I always do that table. And then if there are any intercepts that I haven't got, you can look for those, and then you can sketch the thing. Right, so your horizontal asymptote is going to be, well, it's been pulled down by 2. So it's y is equal to negative 2. Right? Then, when x is negative 1, you're going to get 2e to the negative 1 plus 1, which is 2e to the 0, which is 2 times 1, which is 2, and 2 minus 2 is 0. So I've got negative 1, 0. So I've got my x-intercept, okay, and then this is going to be my y-intercept. So when x is equal to 0, you're going to have 2e minus 2, and you can go work out on your calculator what 2e minus 2 is, and that's going to be that point over there. And when x is equal to 1, you're going to get 2e squared minus 2, and you can go work that out on your calculator, and fill those in, and then go sketch the curve. So, for question K, if you work them out in your calculator, your points are negative 1, 0, 2 decimal places, it'll be 0, 3,44, and then 1, 12,78. So if I plot the points, here's negative 1, 0, here's 0, 3,44. Remember, even if you're working, you must label them, please. And when x is 1, y is 12,78. Join them up. It's a typical exponential curve. Don't forget to label. So you have a mark for your asymptote, a mark for your 2 intercepts, okay, and a mark for your shape maybe. So that would be out of 4 marks. Okay, it must be labeled fully, guys. And there is your function for k. Now, right, in next one we're doing L, and you've got to sketch y is equal to e2 to the x minus e to the x over 3e to the x. So the first thing, often when there's with graphs, if there's a variable in the denominator, there's a vertical asymptote. So I want you to first of all tell me why there isn't a vertical asymptote here. Okay, well done, Morgan. Okay, the reason why there isn't, well, if x is equal to 0, okay, you'd get e to the 0, which is 1, so the denominator would just be 3. So the vertical asymptote, there's no vertical asymptote, because 3e to the x, no matter what x, can never be equal to x. Can never be equal to 0. So there's no vertical asymptote, which is what we expect with an exponential graph. Okay, so what about a horizontal asymptote? Well, I can't see the horizontal asymptote in that form. So what I want you to try to do is simplify this. Okay, and the way you're going to simplify it is go take out a common factor and cancel. Right, off you go. So if I take out a common factor, I'm going to get common factor is e to the x. E to the x times what will give you e to the 2x? Well, times by another e to the x. Because when I multiply powers, what I do to the exponents, you add them, so it'll be e to the 2x if you times that back out, and then minus 1 over 3e to the x. Okay, then the e to the x's, those two e to the x's are going to cancel, and you're going to just be left with y is equal to ex minus 1 over 3. You still can't read off the horizontal asymptote in that form because you need a constant at the end. So it's going to be simply y is equal to e to the x over 3 minus 1 over 3. So that is a form of the equation where we can now identify the vertical shift, which is negative a third down. So your horizontal asymptote is y is equal to negative a third. Okay. Right, then, okay, I always do that table for exponential graphs. So if x is equal to negative 1, okay, you're going to get e to the negative 1. I'm just going to sum it to this form. You're going to get e to the negative 1 minus 1 over 3. Okay, go shove that into your calculator. Okay, and you should get, okay, if x is negative 1, I got negative 0.2, roughly. Okay, if x is equal to 0, y will be equal to e to the 0 minus 1, which is 1 minus 1, which is 0, and 0 divided by 3 is 0. So that's dandy. This graph goes through the origin. And when x is equal to 1, you're going to get e minus 1 over 3. Now, I'm going to label, you really only need the intercepts at one other point at the most. Those 2 points like that, I'm going to label them as 0, 0, and 1, e minus 1 over 3, but I want to know roughly where e minus 1 over 3 is. So I enter that into my calculator, and I got 0.6. So now I use those points to get the scale of the axes. Okay, and we're only going to need negative 1, 1, 1, and negative 1. Okay, first of all, your horizontal asymptote is that y is equal to negative 0.333, negative 1 over 3, which is roughly somewhere here. So draw that in. Here's your horizontal asymptote. Then, when x is negative 1, y is not negative 0.2, which is somewhere over there. You don't have to label that if you don't want to. When x is 0, y is 0. And lastly, when x is equal to 1, y is equal to 0.6. Okay, 0.6 is somewhere over there. But I'm going to label it, okay, because I haven't specified in terms of decimal digits, as 1 e minus 1 over 3. At that point label, I've got the intercepts label, that's enough. Got the asymptote label. Go join that up. Okay, show that it's heading towards your asymptote, and this is the equation of y is equal to ex minus 1 over 3, which is the same as the way the question was originally asked. Okay. Fantastic. Get that done. Good day. Right. The next one we're doing is M, and we start now with line graphs. Okay, so just a general point. When I'm drawing log graphs, so any log graphs, I say I've got log x base a. The points I generally look at, just they're quite convenient, is 1 over your base. So that's a is your base. Okay. So I choose 1 over the base, I choose 1, and I choose my base. And the reason why is if you've got log a 1 over a, it becomes log a to the negative 1. Okay. So you end up with log base a 1 over a, which is a to the negative 1, which is simply going to be negative 1 log a of a, which is going to be negative 1. So I'm going to have 1 over a negative 1. Okay. And then I'm going to have, if x is equal to 1, I'm going to have 0. And if x is equal to, because log 1 is 0, no matter what the base is, and if those two things are the same, and you have log a of a, you're going to have 1. So those are points which are pretty convenient in terms of calculating. You won't need a calculator. The other things I look at, so that gives you an idea of the shape. Probably first I would do this though. Okay. If I've got log a f of x, okay, then the vertical asymptote will happen, okay, when f of x is equal to 0. Okay, that will be your vertical asymptote when that's equal to 0. And your domain, or what goes into a log function, so in this case f of x, must be bigger than 0. So that's generally how I draw log graphs. For more complicated ones, I don't go through all those steps because normally you've got to go find an x-intercept and a y-intercept, and that combined with your asymptote is simply enough to draw the graph. So, first question said go sketch y is equal to ln x, which remember means y is equal to log x base e. So what's your vertical asymptote going to be? Well, it's just with that is equal to naught. So your vertical asymptote is x is equal to naught. Your domain, I would always look at the domain for log graphs. Your domain would be x is bigger than naught. So my graph can only exist to the right of the y-axis. Right? Then, so you've got a vertical asymptote. If I now choose 1 over my base, well, my base is e. So if you put in 1 over e, you get log e of 1 over e, which is log e to the negative 1, which is just simply going to be negative 1. So I'm going to have 1 over e negative 1. If x is equal to 1, you're going to have ln 1, and ln 1 is equal to 0. Okay? And if x is equal to e, you're going to have ln e, and ln e log e base e is equal to 1. So those are the 3 points that I need. Okay, so when x is equal to 1 over e, okay, y is going to be equal to negative 1. So I'm just going to label that 1 over e and negative 1. When x is equal to 1, y is equal to 0. And when x is equal to e, and e is heading to 2,7 something, okay, so it's over there, then y is equal to 1. So that's the point E1, and there is your standard ln graph. There's the graph of y is equal to ln x. Mark there, mark there. Asymptote x is equal to 0. Okay, hope you're comfortable with that. Dumelang. So, next one we're doing is t, and we're sketching y is equal to ln x plus 1 minus t. As soon as log graphs start involving shifts, I don't rush to the table, I just use that table of 1 over the base, 1 in the base, for the basic ones. Okay. For this, well, I would always first look where your vertical asymptote is. And your vertical asymptote is where x plus 1 is going to be equal to naught. Remember, log graphs have a vertical asymptote. So your vertical asymptote is x is equal to negative 1. I would always focus on the domain as well of a log graph, and the domain is going to be where x plus 1 is bigger than 0. So in other words, where x is bigger than negative 1. Okay? Lovely stuff. Now, if you think about it, you're going to have your vertical asymptote there, and chances are you're going to have an x-intercept and a y-intercept, which will be enough to sketch the graph. So for the x-intercept, we're going to let y be equal to 0. So I'm going to get 0 is equal to ln x plus 1 minus 2. Okay, so I'm going to get 2 is equal to the ln of x plus 1. Remember, 2 ln means log base e. Okay, so 2 is equal to log base e, x plus 1. Now, if I use my definition, remember to solve log equations, okay, we can often solve them by changing into the exponential form. So it will become, e will stay my base, that 2 will become my exponent. And I'm going to get e squared is equal to x plus 1. So x is going to be equal to e squared minus 1. Okay, and if you go work out e squared minus 1 on your calculator, you get approximately 6,4. So x is approximately 6,4. So if they said to you what's the coordinates of the x-intercepts and I hadn't specified to decimal places, you're going to say the coordinates are when y is 0, x is e squared minus 1. Okay? So the next one, okay, and that point, by the way, e squared minus 1 is about 6,4. So you can just go label it as e squared minus 1. At that point over there. The y-intercept, if I let x be equal to 0, I get y is equal to ln 1 minus 2, and ln of 1 you should know is 0, so I get 0 minus 2, which is negative 2. So the coordinates of the y-intercept are 0 and negative 2. Okay, and 0, negative 2 is over here. Okay, so I've got that point, and I've got that point at e squared minus 1. Okay, and then I know the vertical asymptote is that x is equal to negative 1. Okay, and label that. There's x is equal to negative 1. Okay, and then you know your basic shape of your log graph. Okay, so you're going to draw that in. Put negative 2 there. So it's going to go like this, flatten out, go through that point over there. It gives a little bit of swiftness. Okay, should go like that. We'd mark that, asymptote, and that is the graph of y is equal to, it should be flattening more, ln x plus 1 minus 2. Voila. Ciao, bella. Don't flatter yourself. Just talking to myself. Right. So, we're going to try u now. I want you to try it yourself first. Question is, sketch y is equal to ln negative x. And again, approach it, tell yourself what's the vertical asymptote, what's the domain, okay, remember the shape of a log graph, and then go figure out your intercepts, okay. If there are two intercepts, there might only be one, then go sketch the graph, okay, have the intercept labeled. If they're both intercepts, that's enough, okay, otherwise find one other point. So, your vertical asymptote happens where that is equal to 0, so in this case, where negative x is equal to 0, so your vertical asymptote is x is equal to 0. So there is your vertical asymptote, which is simply the y-axis. Right, your domain, what goes into a log function, which in this case is negative x, must be bigger than 0. And if I divide an inequality, the direction of the inequality, by negative, the direction of the inequality changes. So the domain is x is less than 0. So I can only put negative values into this function, so the whole graph is going to be to the left of the y-axis. So intercepts, well, the vertical asymptote is x is equal to 0, so it's not going to cut the y-axis, so there's no y-intercept. Okay, but there is going to be an x-intercept, and as you know, to find it, it's where the y-coordinate is 0, so I get 0 is equal to ln negative x. You can do it intuitively, or you can use a definition. And you go 0 is equal to log e of negative x. And then if I change to exponential form, it will become e to the 0 is equal to negative x. So 1 is equal to negative x. So x is equal to negative 1. So this graph must go through the point negative 1, 0. It's going to go through that point over there. Right? And if you want, so we've only got one point. There's the asymptote. I don't have both intercepts, so I should really go find one other point. It's to the left, so let's say what happens when x is negative 2. When x is equal to negative 2, y is equal to ln of negative 2, which is ln 2. Okay, so this graph goes through the point negative 2 ln 2, and ln 2 is approximately 0.7, so it's going to go through negative 2, 0.7 roughly, which is over here, negative 2, 0.7. I'm going to label it though as negative 2 ln 2. So my graph goes through that point and that point. Okay, it's a log graph, so it flattens out and then steepens up towards the asymptote. And there is the graph of y is equal to ln negative x. Okay, label that. One other point, asymptote, get the shape right. Okay, remember, label even if you've done your working out. We've done now up to U, V, Z, and 2A to go.
day.
So, the next one doing is V. Sketch y is equal to ln absolute value of x. Again, if you just look at the vertical asymptote and the domains, things become pretty clear. So the vertical asymptote, well, what goes into a log function can't be equal to 0. So your vertical asymptote is x is equal to 0. And the domain, well, anything that you put in there is going to end up being positive, right? Because the absolute value of anything is positive. So the only thing you can't have is 0. So the domain is x is an element of reals, but x cannot be equal to 0. So there's your domain. So you can go to the left and to the right, but there is, remember, a vertical asymptote at x is equal to 0. Then the intercepts, well, it's never going to cut because that's the asymptote, there's not going to be a y-intercept. So there's no y-intercept. And the x-intercept, well, sub y is equal to 0. And I get 0 is equal to ln absolute value of x, which means 0 is equal to log base e of absolute value of x. And if I use the exponential definition, I get e to the 0 is equal to the absolute value of x. So 1 is equal to absolute value of x. So therefore, x could be 1 or x could be negative 1. Lovely stuff. So in other words, the coordinates of the intercepts are 1, 0, and negative 1, 0. So now to draw the thing, it goes through 1, 0, and negative 1, 0. There's my asymptotes. We may also find another point. If I put in e, I'd get y is equal to ln absolute value of e, which is just ln of e, which is equal to 1. So another point would be e1. E is just before 3, so there's e1. And likewise, if I put in negative e, I get y is equal to ln absolute value of negative e, which is just ln of e, which again is 1. So negative e1 is another point on this function. So there's negative e1, right? And if you sketch the graph, it's a log graph, so it's going to flatten out, get steeper towards the asymptotes. And likewise on this side, it's going to do that. Okay? And that is the graph of y is equal to ln absolute value of x. Okay?
Very pretty indeed. Goedemiddag.
Right. So the next one is question Z. Okay. We've got to sketch y is equal to the absolute value of ln x plus 1. Now remember from grade 1, if you've got y is equal to the absolute value of f of x, well then all your y coordinates will be positive. So the whole graph is going to be above the x-axis, right? And if you've got y is equal to negative absolute value of f of x, then all your y coordinates are negative, so the whole graph will be below the x-axis. So the strategy for the graphs of this form is just sketch a graph of f of x, and then anything which is below the x-axis, you flip above the x-axis. Okay. Again, it's a log graph, so let's start with the vertical asymptote. So the vertical asymptote is going to be when that bit is equal to 0, so when x plus 1 is equal to 0. So in other words, when the vertical asymptote is x is equal to negative 1. So we can call that in and label it. So there's x is equal to negative 1. And then your domain will be when that bit over there, okay, is, remember it's not absolute value of x plus 1, so that still has to be positive. So so it's going to be when x plus 1 is bigger than 0. So a domain is when x is bigger than negative 1. So the graph is going to be to the right, okay, of the line x is equal to negative 1. So then we're going to have the intercepts. Well, if we put x is equal to 0, you're going to get y is equal to the absolute value of ln of 0 plus 1, which is absolute value of ln 1, and absolute value of ln 1 is equal to 0. So that's good news, because it goes through the origin and we don't have to worry about another intercept. That must be the x and the y intercept. Okay, so we should have another point though, and if I let x be equal to 1, y is equal to ln absolute value of ln 1 plus 1, which is absolute value of ln 2, which is ln 2, which is approximately 0,7. So when x is equal to 1, the y value will be just below that. So that would be the point 1 ln 2. Okay. Now, if you are drawing a graph of just ln of x plus 1, well, that part would be like that. And then what would happen is the graph would carry on down towards, steepen up towards the vertical asymptote. But it's because it's of the form absolute value of ln x plus 1, all the y coordinates must be positive, so all the points below the x-axis are going to be flipped above the x-axis in the mirror image. You're going to reflect it about the x-axis, and you're going to get a graph that does that, heading towards the vertical asymptote. Okay, and there you can rub that out then, is the graph of y is equal to the absolute value of ln x plus 1. Okay, just make sure you put that all right. In the interlude, for your viewing pleasure, because we're worried about your mental health, we have drawn for you compliments of Amrin, the great artist, a lovely fish, a thing with funny hair. What is that? A smiley face, a grumpy looking dog, a happy looking pig, and a grumpy looking bird. Okay. For your mental health, feel free to practice doing those. Good day. So, the last question we're doing for today is question 2a from your Mindful Maths, page 119. And you're given the function f of x is negative 3e to the x plus 3. And let's give any labels to 1 decimal digit for the sum. So it's an exponential graph. So go tell me what the equation of the horizontal asymptote is. For exponentials, I always fill in those 3 points. That gives me 3 points, which give me the shape of the graph. Right, so just by doing those two things, go sketch the graph. Right, and if I do that, if I fill in e to the negative 1, I get negative 3 e to the negative 1 plus 3. And if you go shove that into your calculator, you should get 1,9. So you get negative 1,9 is my first point. Negative 1,9. Okay. Let's label that. Negative 1,9. Okay. Then if x is equal to 0, okay, you're going to get negative 3 plus 3, which is 0. So it's going to go through the origin, 0, 0. That point over there. And if x is equal to 1, you get negative 3 times e plus 3, which is a negative number, and it's negative 5,2. So I get 1, negative 5,2. 1 across approximately over here. So I get 1, negative 5,2. Okay, remember that it's going to look like there's a vertical asymptote, but there's not. What is the asymptote? It's exponential, so there's a horizontal asymptote, and the horizontal asymptote is at y is equal to 3. So no vertical asymptote, label the horizontal asymptote, y is equal to 3, and the graph is going to head towards your horizontal asymptote. So it's going to look something like this, flattening out there, and then carrying on. Remember, it goes outwards though forever. It doesn't have a vertical asymptote. It looks like it's got one because it's so steep, but it does not. So this is a graph of f of x is equal to negative 3 e to the x plus 3. Okay, negative 1, 1,9, 0, 0, 1, negative 5,2, and a horizontal asymptote at y is equal to
3.
Right, part 2 of question 2a says go find the equation of f to the negative 1 of x in the form f to the negative 1 of x is equal to something. Well, we know that for equation f, we've got y is equal to negative 3e to the x plus 3. So for f to the negative 1, for an inverse, you swap the x's and the y's around in the equation. So instead of y there, we're going to have x is equal to negative 3e to the y plus 3. But they want it in the form f to the negative 1 of x is equal to something. So somehow we've got to isolate y. So to isolate y, well, we're going to have, if I move that across, x minus 3, okay, divided by negative 3 is going to be equal to e to the y. Let's make that prettier by dividing the top and the bottom by negative 1. So I'm going to get 3 minus x over 3 is equal to e to the y. And now if I convert to the log form of that equation, I'm going to get log base e of 3 minus x over 3 is equal to y. Okay, so in other words, the equation is going to be y is equal to, instead of log e, I'm just going to write it as ln 3 minus x over 3, and I should rather write it as f to the negative 1 of x is equal to ln 3 minus x over 3. Okay, so swap the x and y's around. Okay, go make y the subject of the formula. Okay, by interchanging the log, the exponential equation to a log equation, and then you can get it in the form that you want. Okay, in the next part of the question, they want to sketch f to the negative 1 of x. Well, even if you didn't have the equation, okay, you could still sketch the inverse just by swapping x and y's around. So, first of all, it went through, the original f went through the origin, so that'll go through the origin. Then if I swap negative 1, 1 comma 9 around, I'll have 1 comma 9, negative 1. I'm going to label it here, 1 comma 9, negative 1. So the graph will go through that point and that point. Okay. Then, instead of 1, negative 5, comma 2, it's going to go through negative 5, comma 2, 1. Okay, negative 5, comma 2, 1. This at our horizontal asymptote at y is equal to 3. So this will have a vertical asymptote. Is that 1, comma 9, 1? This will have a vertical asymptote at x is equal to 3, the inverse. This was below less than y is equal to 3, so this will be less than x is equal to 3, so the graph will be to the left of that. Okay? Or you could use the equation and say vertical asymptote will be at x is equal to 3. Okay? When is 3 minus x bigger than 0 over 3? Well, it will be negative x. When 3 minus x is bigger than 0, so when minus x is bigger than minus 3, so when x is less than 3, that will give you the domain of f to the negative 1. Okay, so it's to the left of that, and it's a log graph, so we know the basic shape of a log graph, and it's going to head towards your vertical asymptote, going through that point, 1 comma 9, 1. Okay, that's 1, negative 5 comma 2. Okay, over here, sorry. So 1 comma 9, 1, 1 comma 9, negative 1, sorry. It goes through at that point over there, then it goes through the origin, and then it flattens out and heads towards negative 5 comma 2, 1. Okay, so this, again, it looks like it might have a horizontal asymptote, it doesn't, it's going up forever. Okay, and that is the graph of f to the negative 1. Okay, and that's the graph f to the negative 1 of x is equal to ln 3 minus x over 3. Okay, it's a log graph where x is less than 3. Okay, the next question, they want the domain and range of both graphs. So, I don't know if you can see the purple, but there's the purple graph. Okay, the exponential graph. The domain of any exponential graph is x is an element of reals. And the range was y is less than 3. Okay, even if you didn't have the graph, they would swap around for the inverse. So the range now would be y is an element of reals, because the domain and the range swap around. Okay, and the domain would be x is less than 3, which you can see from the equation. You can also see it from the graph. Okay, the black graph over here, that's your log graph. The domain is x is less than 3. The range is y is an element of reals. Getting there, I know it's been a long lesson. The next thing I want to know is when is f of x less than the inverse of f to the negative 1 over x? Which x does that happen? Well, first of all, where do they intersect? Well, a graph and its inverse are reflections about the line y is equal to x. So they're going to meet at y is equal to x, which is the point 0, 0. So this is where they meet. Okay, the intersection is at 0, 0. Okay, and then when is f of x less than equal to f to the negative 1 of x? Well, f of x, I use colors here, is the purple graph. So what they want to know, when is the purple graph? Below, okay, the black graph. Well, it's below the black graph to the right of this. Okay? So when x is bigger than 0, bigger than or equal to 0, so that's going to be your answer. Because when x is bigger than or equal to 0, f of x, the purple graph, is below f to the negative 1 of x. So that's your solution. Today, thank goodness, says which values of x is f of x, so I'm on the purple graph. When are the y coordinates, it's saying when are the y coordinates bigger than or equal to 1? Well, that's the region in red there where the y coordinates are bigger than or equal to 1. So I'll read off my answer over there on the number line. The problem is I've got to find out which x value goes with a y value of 1. So I want to know when f of x is equal to 1. So when 1 is equal to negative 3e to the x plus 3. Right, so go solve that equation. And you'll get minus 2 is equal to minus 3e to the x. So 2 over 3 is equal to e to the x. So 2 over 3 is equal to e to the x. So change it into a log equation, and I'll get log base e. In other words, let's just do it like that. So log base e of 2 over 3 is going to be x. So ln 2 over 3 is equal to x. So this value over there is ln 2 over 3. Okay, so when is it going to be bigger than 1? Well, it's to the left of ln 2 over 3. So the question says which values of x is f of x bigger than or equal to 1? So when x is less than or equal to ln 2 over 3, that's going to be your answer. If you want to give it to one decimal place, I think it's negative 0,4. You'll have to check. Okay, so when x is less than or equal to negative 0,4, they said to one decimal place. Otherwise, you could leave it like that. Okay guys, and all that's left to do is go look on the WhatsApp group on the message I posted there. I've given you some extra optional examples if you want to sketch a couple of extra things to practice. We've done quite a lot. I don't actually think you have to do more, but if you'd like to do more, okay, you can do some. And that is it for today. Thank you very, very much.